if z is not equal to 1 and z square over z minus 1 is a real number, then the point represented by z in the complex plane will be. We have been provided with some options, so let us start doing this question on the whiteboard. First of all, let us assume that z is equal to any complex number x plus iota y. Now the expression which we have been given is z square over z minus 1. So if we substitute the value of z in this expression, we will be getting x plus iota y whole square divided by x plus iota y minus 1. So that will be equal to x square plus iota y whole square plus 2 iota xy divided by. Now in the denominator we take the real portion on one side and the imaginary part on one side. So that will turn out to be x minus 1 plus iota y. Now as we know that iota square is minus 1, so numerator turns out to be x square minus y square plus 2 iota xy divided by x minus 1 plus iota y. Now we need to convert this expression or this complex number in the standard form, and to do this we need to multiply in numerator and denominator by the conjugate of denominator. So that will be x minus 1 minus iota y. So in the numerator also we are multiplying x minus 1 minus iota y. On simplifying, we will be getting x square minus y square multiplied by x minus 1 minus iota y times x square minus y square plus 2 iota xy times x minus 1 minus, or rather we can say it will be 2 iota xy minus iota y, that will turn out to be plus of 2 xy square, because minus iota, that iota and that iota will become iota square, that will be minus 1, so complete thing will be plus. In the denominator we will be having x minus 1 whole square minus iota square y square, because this is a plus b and a minus b, so that will turn out to be a square minus b square. Now if we separate out the real and imaginary part in the numerator, we will be getting x square minus y square times x minus y plus 2xy square, that's the real part, and the imaginary part will be plus iota 2xy times x minus 1 minus y times x square minus y square divided by, we separate out the real and imaginary part, and that by x minus 1 whole square plus y square, and here also it will be x minus 1 whole square plus y square. Now as in the question it has been stated that number z square over z minus 1 is real, therefore we can say that imaginary part of z square over z minus 1 should be equal to 0. Therefore this portion you can say that where iota is there, that should be 0. So let me write this thing, 2xy times x minus 1 minus y times x square minus y square over x minus 1 whole square plus y square should be equal to 0. Now this will go over there, so that will turn out to be 0 only. Now let us continue this question on the next whiteboard. So we are left with 2xy x minus 1 minus y times x square minus y square equal to 0. What we can do, we can take y common out of it. So we are left with 2x square minus 2x minus x square, this minus will multiply this, and plus y square equal to 0. On simplifying the expression in the bracket, we will be getting 2x square minus x square, that will be equal to x square, then plus y square minus 2x equal to 0. So now we can say that either y is equal to 0 or x square plus y square minus 2x is equal to 0. Now y equal to 0 represents x-axis, and in complex plane we can say that it is real axis, and this expression here we can say that the coefficient of x square and y square is same and the term containing xy is missing, so therefore it will represent a circle. And also we can say that there is no constant term. No constant term is present. So if we substitute the x coordinate as 0 and y coordinate as 0, we get the equation is being satisfied by 0, 0. That is, this circle passes through origin. So we can say that this equation represents the circle passing through origin. So let's see which is the correct answer. Here we can say the option A is saying either on the real axis or on a circle passing through the origin. So this is the correct answer.